Hello and welcome to the Let's Talk Azure podcast with your hosts, Sam Foote.
And Alan Armstrong.
If you're new here, we're a pair of Azure and Office 365 focused IT security professionals. Each episode, we talk about a specific topic in this space. This week, it's episode 18 of season 2. We're going to talk about Microsoft Defender for IoT, a suite of security tooling aimed at securing and managing your IoT assets. Hey, Alan, how are you doing?
Hey Sam, I'm not doing too bad. How are you? How are we on episode 18? Doubling
Uh,
our last season.
I, I know, and we're rapidly coming towards the end of this season. And if anyone that's listening, hopefully, we are going to go up to episode 20 of this season, and then we're going to sort of after episode 20, we are going to have a recap episode, aren't we, to sort of finish out sort of a season finale, if that makes sense. And then we're going to have a little bit of break over the holiday season, and then we're going to come back hopefully early in the new year. Actually, no, we will. I'm not going to say hopefully. Early in the new year, we're going to come back and we're going to smash out season 3. We're not 100% sure. We're currently debating how long season 3 should be, but we're still going to target our weekly cadence of an episode each week. We've got tons of content, haven't we, that we still want to go through and talk about and things like that. So yeah, there's plenty in the pipeline for sure. You're looking forward to it, Alan? I think it's quite exciting at this point.
Yeah, I can't wait.
Yeah, it's going to be great. Okay, so we're going to talk around Defender for IoT. I'm going to be sort of taking the reins in terms of questions from Alan to me. I've sort of been living in the Defender for IoT world for probably the last, and you to some degree as well, I suppose, Alan. But probably for the last 3 months, something like that, maybe. Defender for IoT.
Yeah, it's been about
Um,
that, hasn't it?
yeah, exactly. It's a relatively new space for Microsoft, and it's attempting to fill some gaps, I think, in some people's organizations. But I'll take us all through that, and hopefully, yeah, we should have a good one.
Okay, so let's get started. So really, we need to start with the basics. And so, what is IoT? What's it stand for, and what type of devices are out there?
Okay, so IoT or Internet of Things um, is effectively a different an emerged class of devices, I would say, right? So traditionally you would have um let's talk about in your business for the moment, right? And we'll because IoT is we'll expand it out, but in your business you will have things like servers, um, machines, or what we would class as endpoints, like the laptops and the desktops that maybe your users are using. And then you would have other devices like printers, CCTV systems, um, your audio and video conferencing tooling, many maybe smart thermostats in your buildings, and many different everything in between, basically. And we call those things IoT, Internet of Things. Um, Now, some devices are classified down further than that, which we call OT or operational technology devices. So, if you imagine if you ran a factory or a manufacturing plant, you may have things on. Let's say you've got an assembly line, and let's say you have to monitor the humidity on that assembly line. You might have a sensor or many different sensors or even thousands of sensors on those in those plants monitoring the environment, running your belt system, your packaging systems, and anything you can kind of think of that controls or monitors an environment, um, can be network connected, and feedback that data to a central source. OT devices are generally very, very. I'll call them dumb. In there, they're not. They usually serve one or one function. They have very limited. Usually, they have very limited hardware capability. So, like a temperature sensor, for instance, might report back. The temperature changes every 30 seconds or 15 seconds. very, very low power device, just emitting its signals and its intelligence back. So what you really get is you get, if you imagine like a temperature sensor, as like an OT device, really, like a really basic. All it does is, record like the current temperature, and then you have something like a printer, which is like, I would say, a smarter IoT device, right? It does more functions. It's got more processing power. It maybe runs some embedded like Linux operating system or something like that to manage it, right? So you have these different classes, and different types of IoT devices. You also have things like kiosk devices, ATMs, like I've said, like kiosk devices, like retail kiosk devices, things like that. They might be higher powered machines, so they might be like, say, an Android box or a Linux box running, some sort of custom operating system and application to actually run the display that it's plugged into or something like that. So these devices sometimes, well, a lot of times, fall out of like the enterprise IT space, right? They might be so low powered that they can't be properly endpoint managed and things like that. They might have their own like bespoke operating systems and different protocols that they communicate. So what I'm trying to get at really is there's, in the IoT world, in enterprise IT, you can lock down the different devices that you have. Like you might say, all we buy is Dell laptops, and we buy this one specific type of Dell laptops. We're Windows only. For our servers, we are Windows, or we're Linux only, or we have a small, relatively small mix of different like operating systems. But in the IT world, you have thousands of vendors with thousands of different types of products, um, that are being, leveraged for, say, maybe saving money. Like maybe you've got like a smart thermostat system that is saving your company, money by having setback temperatures on your air conditioning and heating systems overnight to save money. Um, but those devices can pose an issue for, um, uh, IT and security teams to manage, patch, and understand. And so if you imagine, um, you might have a printer that you bought 5 years ago that you're extending the life out on because you don't want to have to buy like a new set of printers. Maybe they haven't been firmware patched for a long time. you know, um, an adversary getting into your network could find, a critical vulnerability with that device. Then use it to move laterally inside of your network, right? So what's so that's kind of why, um, like IoT devices can, be a source of issues for businesses. You also have the same thing, maybe inside your home, like your personal IoT devices. You might have a fridge that can order more milk from some online, grocery store, right? And they are effectively computers built into previously dumb devices. I mean, the idea of a fridge isn't dumb, right? But its function is relatively simple. I have a door, keep it closed, and I keep your things cool. But now it's like integrating. Do you still have, might have a camera system inside to detect, like, how full up your carton of milk is, or and to reorder on a specific frequency. These devices are becoming more and more cloud connected as well. So these devices are talking to external systems. They are effectively controlled by external entities as well. So how do you discover the assets that you have in your organization? Because that is a challenge. And then how do you, sleep easy at night, knowing that you've got, everything up to date, you're configured correctly, and things like that. I might have butchered the reasoning, behind why we should care about IoT, but I think you probably get the gist of what I'm, effectively saying in the TLDR is that these devices sort of fall out the side of traditional IT teams, and management of them. A lot of the times these are managed manually, which is, I would say, a bad thing.
Yeah, absolutely. And for some examples of when IoT has been compromised, I think there was one that was, I think it was in a casino somewhere. I have no idea where it was, but I think the temperature sensor for the fish tank got compromised, and then they were able to take, lateral move from there into the systems and do something. I can't remember what it was. I think that was something I heard about. And I've also had I've heard things around it. This was like 4, 5, 6 years ago when IoT started to come out. Was that you had the really cheap cameras that you used to buy to do some basic CCTV at that point in your house, and that because they default passwords won't change, things like that, that they were compromised. But no one really thought about those as being something to secure.
Yeah. Yeah, we've heard examples of organizations having IoT devices that they have no idea about. Like consumer facing devices that you can buy from big online stores and local, technology stores being acquired by, different silos of the business being implemented, and then them not having any oversight or knowledge around because a lot of these IoT devices, especially consumer-facing ones, are really easy to get set up and moving, right? So you also have like sort of an insider infiltration of IoT devices that you may not even know about. We've had examples of people not knowing that there's like Xboxes and PlayStations plugged into to networks, um, and it's kind of like how do you keep track of that, and how do you and there are definitely um, there are network level protections against that, but I'll talk about that in a bit more depth when we talk about Defender for IoT.
Yeah. Okay. Well, thanks for that overview of IoT. So Microsoft Defender for IoT, how does it help us with this?
Okay, so um, Microsoft Defender for IoT is a I call it I use the wording a suite of tooling, right? Because it is not one thing, and that does sometimes add a bit of confusion to conversations, right? So Defender for IoT is a suite of different products that target different types of IoT device. Okay, so in the enterprise, we have enterprise IoT, right, which is effectively like a subsection of Defender for IoT, and I will go into depth on each of these sections. But what it's really targeted about is IoT devices in enterprise networks. As I mentioned, things like printers, um, AV systems, and different things like that, and also discovering those devices. So the first part about knowing what it is that you have to manage is that you have to discover it and understand it. you know um IT teams may currently keep a Excel sheet of all of their IoT devices in their business, and maybe they check it periodically to understand, whether things need to be patched, and and discovering devices on the network. So what Defender for IoT and kind of all of its implementations is the first part is visibility. So we will attempt to understand all of the devices that are on your networks, because we also understand that there are potentially multiple networks inside of your business. The first area is discovery. So once we know what we've got, we can then start to try and infer information about that device. Maybe the firmware version that it's on, any security misconfigurations that it's got. And a lot of these devices, you can't put an agent on them, right? So there are solutions and techniques, which I'll talk about shortly, which is around like agentless scanning. Like understanding what these devices are without putting an agent actually on them, because some of these devices don't have enough like horsepower to basically run these uh, like an agent. So you've got enterprise IoT, and then you've got sort of, I would say, in the middle, which is what they refer to as um, like more powerful OT devices. I would say so. Your things like your kiosks, your ATMs, things like that. They are. they live outside the enterprise network, but they still do need to be managed and protected. Your if you run a fast food chain and you've got a bunch of kiosk devices, where people order food, how they're not part of like your corporate enterprise network. So how do you make sure that they're patched and kept up to date? Because those machines, they could be Linux machines, like full blown, x86, machines inside of there. So we have for that we have a micro agent, like a Linux micro agent that can be integrated there. So anything that's got enough power that can run Linux, there is a micro agent to handle that device as well. So that's sort of middle of the road devices, where they're like real computers, but they're actually IoT devices that we're trying to, but they're not. They're sort of out in the wild. I'm going to call them like out of your corporate sort of enterprise network. And then the full end of the extreme is Defender for IoT, but for OT. So the OT again, I'll go through OT in depth, but Microsoft is effectively got a different set of tools and collection mechanisms specifically bespoke to OT devices. OT networks are, I'm going to say, weird. They're not weird. Well, from something that comes from like enterprise IT, OT networks are very different than traditional networks, and I'll talk about them when we talk about OT. So Microsoft has made a recent acquisition and got tooling around understanding those types of networks. So really, what all of the different types of Defender for IoT like offering are effectively trying to do is they're trying to identify the devices on the network, um, understand misconfiguration of those devices, understand threats and devices acting in an anomalous fashion, um, and then also connecting all of those TVM, threat vulnerability management. So making sure things are patched and up to date. That's important. And also understanding authorized and non-authorized devices, I think, is a big important one. Like you've got a network that only your CCTV camera system is on, and weirdly you see a Raspberry Pi hit that network. That could be there might be something wrong with that, right? It might be completely harmless. Somebody might have just um, been doing some testing or whatever. But it could also mean that there's been a machine added to that network in an unauthorized way. So there's things around that, and I'll talk to that in a little bit of depth. So you've got all of those areas that we're trying to observe and to understand. But I do just want to hammer home the point, because lots of people get very confused, including me, about this, is that Defender for IoT is a suite of products, many different products for different types of networks, and different types of devices as well. So that's why I'm going to break them down, and really why you should say like Defender for IoT brackets Enterprise IoT, Defender for IoT brackets OT, and Defender for IoT brackets micro agent, because they are that they have to be three different types of product to meet to meet the desired outcomes, basically.
Yeah, we've definitely had some uh, not issues, but fun trying to explain the three types, haven't we? So,
Yep.
yeah,
Yeah,
definitely. So,
and we're not being critical of Microsoft, but it does also come up when we're interacting with Microsoft and other people are interacting with Microsoft, right? I think it's definitely a complex area. So I'm definitely not being critical of their um their documentation and their marketing material on it. But it does take, because of the nature of the environment, it takes time for people to understand those different types, especially if you've got no real exposure to IoT and OT, basically.
yeah, definitely. Okay, so you mentioned enterprise IoT. What do we need to be concerned about, and how does Defender for IoT sort of is helping us? You kind of mentioned a few things, but let's go into a bit more detail.
Okay, so from an enterprise IoT perspective, Defender for IoT is very closely connected to Defender for Endpoint. So I think let's talk about Defender for Endpoint and first. I think so. You've onboarded Defender for Endpoint. You are licensed for it's P2, is it, Alan? I think it's P2.
Yeah, plan to.
Yeah,
Yeah.
you're licensed for Plan 2. Let's say this is the state in which where you are with your organization. As part of Defender for Endpoint, you can pass or even with the endpoints, you can passively and actively scan the network to discover devices. Okay, so your Defender for Endpoint devices will listen for new devices entering the network, and then over time, relatively slowly, I will add, because this is not in network um, intrusion detection, they will actively scan devices that they see on the network. Now, you do have to opt in for these things, but the functionality is there, right, to discover these devices, and it will pick up IoT devices. It will pick up network devices, but there's another thing about network scanning that I won't go into now because it's technically not Defender for IoT. But Defender for Endpoint will discover other machines, Windows, Mac, and Linux, different IoT devices that are on your network. So what we're talking about there is discovery, right? Whereas maybe before, traditionally, in the Defender for Endpoint portal, you would see just your enterprise devices, just your devices that were enrolled into there. But now you're sort of getting a consolidated view of those devices and other devices that you've observed on your network. That is also a little bit confusing because the what those screens are used for is now changing, right? Because that list can now have, I'll call them unauthorized devices being added to them. Whereas before it was just like, these are the machines that I definitely knew about and I cared about. My desk, my endpoints and my
You
servers or
managed, yeah, you
whatever.
managed
Your
endpoints.
managed devices. Yeah, great. Thank you, Alan. So yeah, your managed devices. But now you've got your unmanaged devices in there as well. You can filter what networks are scanned, and it won't scan people's home networks and things like that. So there are some protections in place there. So the discovery element can that basic element can be covered by just Defender for Endpoint Plan 2. What Defender for IoT then does, so what you do is you activate a license. You'd actually do it in the endpoint side, which is a little bit confusing. Again, it's not in the Defender for IoT side. You enable a license inside of there, and then what you'll get is you'll get a risk score for that, a risk score and a TVM score for that device. And what that's effectively doing is, if the device is acting strangely and it's causing Defender for Endpoint to have alerts from other managed endpoints, managed devices, your risk level will start to increase. And then your TVM score will change if the scanning has detected like older versions of maybe your firmware or your operating system, if it's able to actually find that information. Because all we are doing is we are actively probing that device from what we can get back. Like, what can we get back from NetBIOS? What can we get back from how it's talking over the network, if we can see that broadcast traffic, and things like that. So that's lovely if you're on a network that has managed devices that have endpoint on them, Defender for Endpoint on them. On networks that don't have um, any devices like roam to them, let's say you've got a CCTV network, there are no managed endpoints, managed devices on those networks. So what do you do in that scenario? Because you can't observe what goes on to that network. So what Microsoft have is they have an enterprise IoT sensor currently in preview as the time that we're talking now. But what that will do is that is a uh, an Ubuntu package. That one, isn't it? It's the package that you install onto an Ubuntu server. And what you do is you connect it to a span port of a switch, and it will effectively look at all the traffic that's running on that network, and passively scan for devices, how they're talking, their firmware, and things like that. Um, we've been advised that you shouldn't double up. Uh, there's no sense in doubling up those two different methods. Like scanning from your managed devices and that enterprise IoT sensor. Um, there is a bit of an overlap when you have like a network where you know um, managed devices sometimes roam to them, where you have to have a bit of overlap, but generally it's no managed devices on a network use the enterprise scanner versus using the endpoint or the managed devices to actually do the scanning. So what's really the benefit of knowing? Well, first is discovery. You know the devices that are on your network, and you also hopefully have some information about the metadata of that device. Maybe who the manufacturer is, a description of the device. So, like, let's say you see an Apple TV on your network, you'll see Apple TV, and you might see what version of what version of software that it's effectively running. What that's really powerful for is if you're um, so pause that just 1 second. Actually, let's talk about Sentinel. So these devices are effectively um, mixed in with your other device data that you have, um, possibly flowing into Sentinel already. Um, so if you do utilize Sentinel, you will get device information, device info, device alerts, and things like that. You can flow those relatively trivially into Sentinel already. These IoT devices are, in essence, very similar. They're in the same tables of data. They're just a different classification of device type. Then what's great is if an alert is then raised in Defender on Defender side or Sentinel side, when you're investigating that, you'll see enriched data about that device. So before, let's say somebody is taking control of a smart TV. They've sideloaded a root level app into your smart TV. Then they start to port scan some of the machines that are on the network. And let's say Defender for Endpoint then kicks in and goes, "Hey, this is weird. I'm getting port scanned constantly by this, this device. Previously, you would just have an IP address, and very basic information. But now, because you've actually got enriched information, you can say, hey, why is my printer port scanning like the CEO's laptop? That's a bit weird, isn't it? Right? And that's very trivial and basic example just for this explanation. But you can see how that would, if you're responding to that incident, it's going to give you a lot more information and context around what is going on there. So you can say, okay, I know that's that's the CEO's printer in the CEO's office. Okay, well maybe so then what can we actually do about that, in that scenario? Well, what is really, and I think one of the best parts of it is you can effectively contain that device. What containment does is it allows you to effectively send out firewall rules to all of your um, managed devices to say, I don't want you to talk to this device anymore. Completely block all communication with it. So it's not done at the network level. You don't have to talk to your network team or your infrastructure team to make that happen and to kick that device off the network and do those different things. There is tooling around that, which is still very powerful and important. I completely accept that. But effectively, this allows you as a managed device administrator, I'll call it, to decide whether those managed devices can actually communicate with an IoT device. And the block happens rapidly, um, very, very, very quickly,
It's
doesn't
about
it?
15 seconds or something, isn't it?
Yeah, it's 15 seconds. If you've ever used isolation of uh, MDE devices or managed device or MDE devices. That's the right way of saying it, isn't it, Alan?
Yeah.
MDE devices. If
Mhm.
you've ever used isolation is instant, isn't it?
It's
Right? If you
like a
isolate a
second, if
device,
that.
yeah, it's
Yeah.
like a second. So it is a little bit slower, but it's still 15 seconds. So if you're investigating that alert, you might say, okay, the printer's acting weird, right? It's port scanning the network. It might be worth me containing that device just so that at least my managed devices are protected, in that instant. And like Alan mentioned, you get 15-second response to that. So that's from an incident perspective. And also you can do things like add in rules which say, if I observe new IoT devices on this network, then I want to be alerted. And you can do some more bespoke. You have to set them up, but you could say on network B, if I ever see a new device, then instantly contain it when it joins. Like I don't want that to talk to any of my managed devices or alert me every single time so that I can be told about that. So those connections are in place. I just briefly mentioned as well misconfigurations. So if you've got say you've got an unauthenticated telnet port on your printer. That's an example that Microsoft used, so I'm just going to regurgitate it for this call. Um, got an open telnet port that's unauthenticated. Um, that'll be scanned and it'll be reported as a misconfiguration. Also TVM. So TVM can be sometimes limited because effectively you're probing the device. You don't have an agent on the device, so you can't get not always full software inventory, but you do get some inventory and some operating system. Um, it's constantly evaluating that against its TVM database to give you alerting in terms of what needs to be updated and things like that. So just to recap, completely sort of MDE focused. It is a requirement. You have to have done your MDE deployment, and you need to be plan 2 as well to get full advantage of this. Plus the uplift of the Defender for IoT license. And just to make you aware as well, because I haven't described it already, there is a Defender for IoT portal in Azure. Now, if you are just doing enterprise IoT, you do not need to use that portal at all. Okay. This was a very confusing part of our understanding of the product is what portal should you look at? Should you look at the Defender portal or should you look at the Defender for IoT portal? And if you're just doing enterprise IoT, pro tip, do not use the Defender for IoT portal, in my opinion. It is possible to use both, but you're going to get that holistic view and you're going to get all the niceties of the Defender for Endpoint, the Defender portal, basically. Sorry, bit of a beast, but yeah, each one of these things is quite in depth.
Yeah.
Each of these areas, if that makes sense.
Yeah, just quickly to talk about the containing, whilst we can contain a device, we can also uncontain it. So it could be that fast response, like you were saying, Sam, contain it once you've seen it just in case. Then you can still talk to your network team to then start blocking on the network, but you've done that first bit. And then
Exactly.
if you do manage to find it, because again, this could be in a remote office that you've got to go and call somebody to
Yeah.
go and check it
Yeah.
out and stuff like that, and go and check that team in another time zone. It could be anything at this point. So
Yeah.
rapid
Yeah.
response to stop managed devices from being able to be being scanned or being potentially compromised by that device, but easily uncontained at the same time. So yeah, it is really good. Okay.
Yeah. I completely agree.
Yes. So okay. So on to the next thing, the micro agent, Linux micro agent. What is it used for, and why is it important?
Okay, so if you've got I'll call them sort of middle of the road sort of IoT devices. You know, machines that maybe are quite low powered, but they actually do run like a proper Linux operating system. Um, it might be tempting to put Defender for Endpoint on those devices, but some of them simply don't have the correct resources there, and the EDR sort of response may be limited in terms of certain configurations, right? And they might not even be supported, right? You know, because um, Defender for Endpoint on Linux is really around desktops, right? You know, like and that sort of a class of device and servers, obviously. Um, So if we're talking about, say, a kiosk device or something like that, or an embedded device, so like Microsoft talks in depth around OEMs, so people building sort of integrated. They talk a lot about healthcare. I believe a lot of those devices are like real computers running operating systems, and managing those is complex. We're really talking around embedded machines that run, um, full blown Linux installations. But we might also be talking about smaller things. We might be talking about a Raspberry Pi Nano that's got very limited computing resources, and you might want to utilize that for your specific application. So the micro agent has a tight integration with IoT Hub. So if you've got an IoT device that is reporting back to IoT Hub, you will see any of their recommendations directly in the IoT Hub that you're connected to. And yeah, specific IoT related recommendations and alerting, versus like a traditional endpoint. You can configure the micro agent a lot more as well in terms of the resources, the logs that it collects, and also the frequency at which it communicates back. Like an IoT network technology that we've got in the UK is called Sigfox. Sigfox only allows you, I believe, to communicate back like once every minute. So some IoT devices could be on, you know, networks that only allow limited amounts of bandwidth, or maybe only have signal at certain times of the day, and things like that. So the micro agent is very configurable in terms of how it collects that information and sends it back to also balance network and also CPU, and resources. I haven't actually deployed the micro agent yet, because it's not really a focus that we've currently got at the moment. In terms of our learning, but that's it's definitely on the horizon for me soon. Also, the micro agent has a CIS benchmark in terms of the configuration of the device. So you do get a level of like security baselining and hardening, as well as threat detection and things like that. So, for instance, I'll give you an example of some of the alerts that can throw is if somebody say clears the bash history on the device. Somebody's gone in and done something and then cleared their bash history. Things like that. There's lots of different alerts that will come out the system, and they are really well documented. If you compare that against, say, the alerts that might come out of Defender for Endpoint, you are getting sight of very specific IoT threats and alerts coming out, which is really powerful. So yeah, really configurable micro agent that can be used on low power devices, but again needs a Linux operating system to function.
Okay, great. So the the last section, or last section of the three types of Defender for IoT, OT. What? How can it help in that bit?
Okay, so OT, as I've explained before, are traditionally a lot lower resourced devices. Like switches, temperature probes, monitors, actuators, PLCs. Like they're doing one function and one function really well. Usually in manufacturing industry, and those sorts of things. OT is quite an interesting type of network. I won't go into it in too much depth because there's quite a different few ways that things can be set up, but generally, um, these devices are so low powered that they can't actually use things like TLS to encrypt traffic back to whatever they're talking to. So a lot of them will talk like completely unencrypted across the network. A lot of things will broadcast the data that they've got. So what you'll have is a very sort of traditionally like a bunch of devices that are more susceptible to to interruption and interference because the protocols that they talk on are completely unencrypted, and they're a lot more vulnerable in terms of their management because they don't have enough resources to actually manage them. They're also they speak so many different protocols, right? So you might buy a one set of probes and monitors from one vendor, and then you might buy a completely different set of tooling for another vendor, but they might work on the same assembly line or whatever. So I think it's fair to say that the world of IoT is a bit of a wild west. I mean, IoT itself is a bit of a wild west, but OT is, even more. I would say. Um, so you have different types of devices, different vendors talking different protocols and talking in different ways. Then you have devices that have very low power and minimal ability to actually manage those devices. Microsoft recently acquired a product called CyberX, which effectively is an appliance that um, you provision inside of the organization. Very similar to the EIoT sensor, it connects to a SPAN port. That is important because a lot of these OT networks are built and then they never want to be touched ever again. And the reason for that is because once you have your manufacturing process dialed, any downtime to that network or those devices effectively costs a company money. You run an assembly line 24/7. Every hour that's out is, lost output that you're never going to get back. So instead of joining the device to the network, we use a span port to observe those networks. Now what now this appliance has to be different to the enterprise IoT sensor. The enterprise IoT sensor isn't, attempting to understand what's being spoken on these protocols. It's just effectively looking for traffic from different devices and fingerprinting it. But the OT sensor effectively is analyzing all of that traffic that's going through it to try and understand if any of those devices are talking in an anomalous way. So the requirements for that sensor are a lot higher. You need for if you've got a network that has decent throughput or consistent throughput, you do need to have an appliance that is quite beefy in order to run that. You can buy a pre-configured device from a partner that Microsoft has aligned with, and there are people like Dell and other vendors that are actually producing like ruggedized devices that are up to spec to run the sensor. So you'll connect the sensor and it will baseline your network for you. So to start off with, it will look at the traffic that's happening inside of your network and understand what's talking to what looks like normal data and protocols that are being spoken, and it'll baseline your environment for you. You can also set like things like, do I know that this device is authorized, and things like that. Um, And then once it's baselined, it will effectively monitor that network continuously for different threats that are being found, new devices that are being added. Let's say your temperature thermometer. Let's say your temperature probe is started acting weird and it's talking to a different device that it shouldn't talk to. Have you made a legitimate change, inside your network, or is that actually some sort of threat actor, changing, how your system, maybe they're turning off the temperature sensors so that your air conditioning system doesn't work, and then it turns off your fridges and your freezers, so they shut down or something like that. OT networks are highly specific to the businesses that run them. So I think that's one big thing to say is they are completely alien types of networks that are built bespoke for a certain business requirement. But because of this, and because of the harsh environments that the OT sensor can live in, you've got things like it's offline capable. So you can run a management console locally, have a numbers of different sensors firing back to that management console. For instance, like threat data, TVM, threat data, and intelligence is actually sent down to the device for the processing itself. So it's not like in um, enterprise IoT where a service in Azure is looking for those alerts. It's doing it on the box itself, and then if you do have, say, a Sentinel connection, because you can cloud connect these sensors. If you cloud connect these sensors, you essentially get a copy of the device inventory and the alerts that have come off those devices. Then, if you do have a cloud connected sensor, then you can push those alerts and that understanding into Sentinel to get. And Microsoft sort of explain it, if you're looking at XDR, and really quick introduction to it, XDR is effectively um, extended detection and response, I think is the acronym, and effectively that's looking at all the different areas of your business in terms of threats and vulnerabilities and alerting into one singular place, which is effectively bringing everything into Sentinel. um, Defender for IoT and OT especially is getting that those alerts and that intelligence out of those OT networks in a safe way, not to interrupt them, and then fire all of that intelligence into Sentinel for Sentinel to then alert and do incident management on. I think that's fair to say, isn't it, Alan? Is that a good sort of
Yep.
primer for OT? Yeah, and each of these technologies could be an episode in itself. So I am just sort of giving you the high level of it. So if you don't have any clients that are manufacturing, or you don't work in a business that has manufacturing, OT is probably not going to be something that you need to, you're going to need to cover. But certainly enterprise IoT and even maybe the Linux micro agent might come into under your purview at any one time.
Yeah, and just one quick thing about OT as well is that those environments rarely change. It's not like enterprise, the enterprise IoT space where you got devices turning up and disappearing, things like that. OT tends to stay. This is what I've got. It will never change. So if I do see a new device on there, I should be concerned. The other thing
Exactly.
we've
Yeah.
seen is that organizations with with an OT environment have said, "Oh, we've decommissioned this subset of systems or sensors," and yet the Defender for IT sensor detects it, and they're like, "Oh, it's still on. Why is it still on?" That sort of stuff. So
Yeah, exactly.
there's things like
Yeah.
that, and as
Yeah.
we've always said, discovery is key to everything. So
Exactly, yeah. You can't understand and manage something you haven't discovered or haven't got any, and unfortunately there are businesses out there that don't have that level of visibility that they should do, you know. And this is where, you know, um, compromises and threats start to appear in systems that are outdated and unmanaged.
yeah, okay. So I'm sure the listeners have all been waiting for this bit. How much did it cost, Sam?
Okay, so so as I mentioned, right, so enterprise IoT, right? If you've currently got Defender for Endpoint Plan 2 and that rolled out, you can do the discovery part of it. But if you don't license Defender for IoT, you will not get things like TVM and a risk score, for that device. So, in order to get that and that element of it, it's $80. I'm going to just work in dollars because this is the numbers that I've got. $80 per month per 100 devices. And the license is a bit weird. You have to sort of self-declare how many devices you have. So you get a 30-day free trial. I think that's a good Good thing to mention as well. Up to 1,000 devices, 30-day free trial. So what you can do is you can discover your devices free of charge, work out how many you've got, and then license them appropriately. But the licensing is a bit weird because you declare how many batches of 100 devices that you've got. So it is a bit weird, I would say. So it's not like consumption. It's not like 80 cents per device, and it just bills you at the end of the month for how many devices it's seen that month. It's different to that. And then if if you've got a device that is connected to an IoT hub, say the Linux micro agent, the costs are massively reduced because you're effectively paying your ingestion cost to IoT Hub already. So your Defender for IoT pricing is a lot lower. So, for instance, um, per device is like $0.001 per month, and then for every 25,000 transactions, um, it's 20 cents. So that you pay that on top of your normal transaction costs, basically, to IoT Hub. So your the licensing is done slightly different because it's running through IoT Hub at that point. It's just effectively like an extension of the IoT Hub cost on top, basically. Oh, sorry, I got that wrong. It's $85 per month per 100 devices for enterprise IoT. My apologies. I got that one wrong. And then, if you would like Defender for IoT um, uh, agentless monitoring, so like the OT side of things, you're looking at $140 per month per 100 devices. You can pay for this side annually as well, but I don't think you get a discount, so I'm not really sure. Except for ease of billing, I'm not sure why you do that. I think the discrepancy between the $85 and the $140 is because you're already paying for on the Defender for Endpoint side, you're already paying for Defender for Endpoint, which is doing a lot of the heavy lifting and the work, for the solution. So if you're just deploying, the OT appliance and the OT appliance and sensor, then you're getting the full, functionality and solution that's giving you, and also being able to cloud connect your devices.
Yeah, and I suppose with the OT side, it doesn't change that often. So that number, you should be easily
Yep.
be able to calculate that, and it shouldn't chop and change too much. The problem with
Yeah.
enterprise IoT is you could roll out another 100 devices because you're having a new phone system or something or whatever it might be. So
Exactly. Yeah. Yeah. So hopefully you're going to be able to just say, we're an OT business with 500 devices. You license your 500, you pay your money, job done, basically.
okay, great. So I think we're coming to the end now. We are at 53-ish minutes,
Yeah. Let's
give or
wrap
take.
this up. People have got things to do.
Yeah.
Yeah.
Okay, so a quick reflection, review, high level review of the features and stuff. So IoT is a complex landscape, and there is lots of different of types of devices that we've talked about today. Um, Microsoft is covering mainly different types of IoT devices. So this is we've talked about enterprise IoT, that sort of middle bit of IoT, and then the OT side. Um, the main one of the big benefits straight out of the box is giving that visibility of all your assets within those different environments and identifying threats and alerts and feeding that into Sentinel, being able to see it, those threats coming in, because as we said, generally an OT environment is never monitored because of its
Yeah.
old age, and it's never really patched and things like that, is it?
Yeah.
If it's not
And
broken, don't
yeah.
fix it.
Don't fix it. Well, yeah,
Or don't touch it. I
yeah.
should don't
I
update it.
agree why somebody would say that, but yeah, sometimes it's not the best thing,
No.
from a security perspective. But yes, and I think the big thing here is the cloud connected aspect of it, right? You are going to have customers that can't do some of these things because of not wanting to cloud connect certain things, and especially in the OT side, there are ways around that. Um, but really you're getting visibility of these devices, and then you're flowing them all the way back up into Sentinel, and then Sentinel is your all-seeing eye, so to speak, of your logs and alerts inside your organization. And it's going to beat that drum of XDR and pushing data into one single pane. Cool. Alan, do you want to tease the next episode?
Yep. So based on our episode around serverless app stuff that we did, infrastructure or serverless compute, we're going to look at Power Platform as a low code, no code environment. So talk about the Power Apps, the Power Automate, and Power BI, and how
Okay.
a simple but a citizen developer can build something within Office 365 and even come out of that and be quite advanced, build a quite an advanced application or solution.
Yeah, adding value to businesses without needing a full development team, I think is a really powerful thing. So yeah, it's going to be a great episode for sure. If you've enjoyed this episode, please do consider subscribing if you'd like to listen to more of this sort of content in the future. We have many topics that we'd like to cover, and your listens and support is what will continue to fuel the podcast going forward.
We also have the ability for you to give us feedback. Did you enjoy this episode? Disagree with our thoughts, or were there anything that we missed? Um, Please use the form that is available in the show notes, um, and we'd love to hear your feedback.
Well, thanks very much, Alan, and we'll speak to you all in the next one.
Yep. Thanks for listening, everyone. Speak to you soon. Bye.